every Sunday, 1 to 3 in the library, or the cafe at the library. The speech will be about Darwin's response to an ethical dilemma when a young scientist named Alfred Russel Wallace presented him with a manuscript containing a similar theory of evolution through natural selection to the one that Darwin had left unpublished for 20 years while he collected further data. Darwin's ethical handling of the situation, as we will hear, gives us a model to emulate as we ask ourselves the question, what would Darwin do? The speaker is James Tabery, a PhD, MA, and he is an assistant professor of philosophy and a member of the Division of Medical Ethics and Humanities at the University of Utah. He received his PhD from the Department of History and Philosophy of Science, as well as his MA from the Center for Bioethics in 2007 at the University of Pittsburgh. His interests lie at the intersection of the philosophy of science and bioethics. Debates over causation and the nature-nurture debate and the ethical implications of those debates, scientific explanations of psychopathy and the legal implications of understanding the causes of bad behavior when it comes to attributions of responsibility and punishment, epistemological considerations in the design of human experiments and the implications for ethical oversight of research on humans. He has published articles in a range of scientific, philosophy of science, and bioethics journals, such as Philosophy of Science, Biology and Philosophy, Stanford Encyclopedia of Philosophy, Journal of Medicine and Philosophy, Journal of the History of Biology, International Journal of Epidemiology, and Development of Psychopathology. And one last announcement before he gives his lecture. P.Z. Myers, who is a renowned author, will be speaking at the university, which is also hosted by SHIFT on the 7th of April. All right, so Dr. Tabery, thank you. Yeah.
So yeah, I also want to, can you guys hear me in the back? Yep. Okay, good. I also want to thank SHIFT for having me here today, and particularly Jason Cooper-Ryder for the invitation. And then finally, I'll thank all of you for risking being naturally selected and coming out to this storm tonight. That was great. So we're here for Darwin Day. This is the 203rd anniversary of his birth. And all over the world, I think there's something kind of really interesting about that right now all over the world, people are celebrating Darwin's scientific legacy. And so what I'm going to do, though, is something a little bit different and think about a different legacy of Darwin's, and that's what his ethical legacy is. I think the best way to kind of convey what I want to share with you today is in terms of visions. And I think the best way to convey my vision is in contrast to another vision. And there's a nice little cartoon here, which is the other vision. Yeah, so this was a cartoon that appeared in the New Yorker a couple of years ago. And it's funny because I think there's something kind of common about the idea, and that is that Darwin equals origin of species, and origin of species equals assault on religion, and assault on religion in turn equals assault on ethics and morality. And so the kind of vision that I want to share with you today is that that's not necessarily the case. That in fact, Darwin and assault on ethics and morality really couldn't be further from the truth. And so if there's anybody here that actually shares that vision and kind of sees those things lining up, I'm hoping I'll kind of give you something to chew on and think about that maybe that's not the case. I would imagine, since most people are here with invitations via SHIFT and Utah Coalition of Reason, that actually you're not in that camp. And so if you're in the other camp, then I'm hoping that I'll just kind of give you a nice anecdote so that if you do encounter somebody who kind of has this worldview, you'll be able to say, well, wait a second, I think we should think about this a little bit differently. So here's how I'm going to approach the topic. As was just said, I'm going to look at an ethical dilemma that Darwin found himself in, and we're going to look at how he handled that dilemma. So I'll introduce that dilemma first, and then I'll take a step back and point out that actually ethical dilemmas in science aren't all that rare. And in fact, what Darwin found himself in is quite common. We'll then drop down to the third section where we'll introduce kind of how modern science bodies like the National Institutes of Health and the National Science Foundation are now more or less mandating ethics education in light of this history. And then we'll kind of bring it back up to Darwin's dilemma and bring it full circle, and we'll think about how he actually dealt with the problem. So let's start with the actual dilemma that Darwin found himself in. So, 230th anniversary, he was born in 1809. He initially had dreams of being a physician, a surgeon, and then when he saw surgery done on a child, it was actually kind of too much for him to handle, and so he gave up on that. He was then thinking about going into clergy and joining the Anglican Church. I think where most people pick up Darwin, right, when they think of him first, is the Voyage of the Beagle. Right? So this was between 1831 and 1836. And Darwin was interested in biology. He was interested in biology throughout his life, and this was a great opportunity. And being at Cambridge, getting prepared to be Anglican church clergy, gave him access to the people that tapped him into the scientific community in Britain in that day. And so, in 1831, he was brought on to go on the Voyage of the Beagle. He had two tasks on that trip. Excuse me. The first task was he was supposed to be a gentleman friend to the captain. The captain was Robert Fitzroy. This was the second voyage of the Beagle. The first voyage of the Beagle, the captain at that time killed himself because of depression and anxiety, and Fitzroy had to take over in the midst of that. And so Fitzroy, seeing what happened to the captain on the first voyage of the Beagle, when it came time for the second voyage of the Beagle, he said, I'm not going to let that happen to me, so I'll get a gentleman friend. And he really had no idea what he signed up for. He signed up for Darwin. So that was his kind of personal obligation. The scientific task was, in 1831, Charles Lyell's Principles of Geology came out, and that's considered really the kind of groundbreaking text in geology. It's what took geology from what we would think of as a hobby or a pastime and made it a science. And so that just came out in 1831, and Darwin's kind of scientific task was to, as they're going around the globe, collect data that was relevant to the geological principles of uniformitarianism that Lyell espoused in that treatise. So he comes back in 1836. Two things come of this. One, Darwin is immediately a celebrity. The whole time he's sending samples that he's finding back to London, and people are readily awaiting his return to hear what he has to say. The other thing that happened was he first had the idea that the species he was encountering, and in particular I think most people think of the Galapagos Islands, could shed light on what was called that mystery of mysteries. And that mystery of mysteries was the transmutation of species. How does one species change into another? And Darwin thought he was getting at that while he was on this trip. This is 1836. When historians go back and look at Darwin's notebooks, it's pretty clear that about 1838, Darwin has evolution by natural selection. Okay? So when is The Origin of Species published?
1859.
1859, that's right, Jason. So now we've got this 21-year gap between I've got the theory of evolution by natural selection and the actual publication of Origin of Species, which is what we associate with being the introduction to that theory. So what was going on in this intermediate 2 decades? Basically what Darwin was doing was he realized he had a very controversial theory on his hands, and so he wanted to gather as much data as possible to make the case for evolution by natural selection. And so we went back and looked at a bunch of the finches that were collected in the Galapagos and looking at how they were responding to the various environmental pressures. We thought maybe there was one original finch that came over, and then the different beaks, which the various famous for, were responsive to different seed size. He actually did experiments on earthworms. He was interested in the kind of relationship between earthworms and the environments which they lived in. And so he actually kind of dug ditches and stuff on his grounds and examined how the earthworms churned up earth. For almost a decade, he did research on barnacles. He was honing his skills as a comparative anatomist and taxonomist. And so he was collecting barnacles from all over the place and dissecting them. And he was also a pigeon fancier. He grew pigeons, or I guess raised pigeons. He had other pigeon fanciers all over the world send them examples of the pigeons that they were breeding, because he was interested in the kind of variation that humans could force on organisms if that's what they were interested in doing. So that then brings us to this guy. Remember, Darwin's basically from 1838 through 1858 is where we'll pick it up, just doing more and more data. Collecting more and more data, doing more and more research. 2 other things that are happening during this time. Darwin is constantly suffering from psychosomatic illness. He has terrible stomach problems, constantly in fever. And the other thing that's happening is Lyell, who now knows about Darwin and what Darwin's working on, is encouraging him to publish. But Darwin keeps putting it off, saying, I don't have enough data yet, I don't have enough examples, I need to continue this way. So Wallace is playing out in London. That fellow there, Alfred Russel Wallace, is in, at the time was the Malay archipelago, kind of Malaysia and Indonesia and Southeast Asia. And he was about 10 or 15 years Darwin's junior. And like Darwin, if you wanted to be a man of science at that time, what you did was went off and explored some area of the British Empire that nobody had explored yet, and sent samples back. And so that's what Wallace was doing in the 1840s and 1850s. And throughout this period, starting in around the 1850s, Wallace and Darwin start communicating. So even though Darwin hasn't published Origin of Species, it's more or less known in the scientific community that he's working on the mystery of mysteries, and he's collecting data thinking about that problem. And so Wallace is throwing ideas off of Darwin. He's corresponding with him from Malaysia, sending him letters, sending him manuscripts he's working on, telling him to share them with Lyell, to get Lyell's feedback. It appears that we don't have Darwin's side of the correspondence, but we have Wallace's letters, all the letters that Darwin sent him, he saved. It appears that around 1855, Wallace was getting close to an idea of evolution by natural selection. He sends a manuscript to Darwin. Darwin passes it on to Lyell. Again, Lyell says, look, you got to publish. This guy's getting close. Darwin brushes him off. He says he's actually really far away. He's still thinking in terms of special creation and kind of divine intervention. I got to keep collecting more data. So all that changes on June 18, 1858. That is the day that Darwin receives from Wallace on the tendency of varieties to depart indefinitely from the original type. According to Wallace, in his autobiography, in a malarial fever one night, the final piece of the puzzle kind of fell into place for him. It was really the same piece of the puzzle as it was for Darwin. This was Malthus's kind of population dynamics and the struggle for survival. And he gets evolution by natural selection. It's not the same exact theory as Darwin, so it doesn't use the term natural selection, but the basic process and the mechanism of evolution by natural selection is all laid out in that manuscript. Darwin receives it. He quickly turns around and writes a letter to Lyell, and as you can see here, he was completely shocked. I never saw a more striking coincidence. If my manuscript sketch written out in 1842, he couldn't have made a better short abstract. Even his terms now stand as heads of my chapters. All my originality, whatever it may amount to, will be smashed. And so, this is Darwin's dilemma. He spent 20 years working on this, and now this whippersnapper sends him a couple-page manuscript that has his entire theory worked out. I can remember when I was a grad student and I was working on a dissertation chapter, and I found just a journal that had just been published, and in it was an article with the same idea that I've been working on in this dissertation chapter for about 6 or 7 months. And I was absolutely crushed. I remember thinking, this is awful, I had this great idea, and now this guy's completely scooped me, right? Now the last 6 or 7 months of my life have been wasted. And obviously you kind of go on with it, right? But imagine kind of multiplying that by 20 or 30 times, right? Darwin's been spending 2 decades, half of his life at this point, working out his theory, collecting data for his theory, and now this kid comes along and sends him a manuscript and it's all right there. So what is he going to do? So we're going to come back to that. I'll leave you guys hanging there for a second. And the reason we're going to come back to it is I want to look at some other ethical dilemmas from the history of science and see how some other scientists handled them, because I think that context will put us in a better position to appreciate what it is that Darwin actually ended up doing. I'll give you 3 examples. Here's one. Does anybody recognize who that is? Watson and Crick, exactly. We now think of the Watson-Crick model of DNA. They're famous for having given us the structure of DNA with the famous double helix, right? And they win the Nobel Prize in 1962 for that. Okay? Watson and Crick are working at Cambridge, and throughout the early 1950s, they're toying around with different models, but they're having trouble getting kind of that last bit of data that will figure out how to put their model together. And the real problem that they were having was neither of them was an exceptionally good X-ray crystallographer. And an X-ray crystallographer gives you the kind of images of what DNA looks like. So one day in January 1953, Watson, he's the squirrely looking one there on the left. He goes and visits Maurice Wilkins at King's College London across town. They both know they're working on DNA. Watson's kind of talking about the trouble he's having. And Wilkins shows him this picture. That's photo 51, actually has a name to it. That is an X-ray crystallographic photo of DNA. And basically, by looking at that X layout, and more importantly, how far and how relatively apart those black lines are, you can infer something about the structure. And this is actually the last bit of information, the last data point that Watson and Crick needed, but couldn't get on their own to put together their model of DNA. So Watson's kind of looking at Wilkins' drawing and saying, oh, that's really interesting, and kind of jotting it down on the side. And he runs back to Cambridge, shows it to Crick, and they tinker with their model in light of these new measurements, and then they get the double helical structure of DNA. Here's the twist. Was it Wilkins' photo? No, it was not Wilkins' photo. It was Rosalind Franklin's photo. She was an excellent X-ray crystallographer working at King's College under Maurice Wilkins. And without her permission or even knowledge, Wilkins takes this photo and gives it to Watson, or shows it to Watson. So now we've got another ethical dilemma. What are Watson and Crick going to do about the fact that they got their last bit of data from Rosalind Franklin? The answer, they're not going to do anything about it. They go off and publish the structure of DNA, and it's Watson and Crick. And we now think of Watson and Crick as producing that structure. 1962, Watson, Crick, and Wilkins win the Nobel Prize. Rosalind Franklin had already died at that point. She died of cancer in 1958, so she's left out. So that's one example of something you can do when you're posed with an ethical dilemma. Here's one that hits a little bit closer to home. Most people, I'm sure, all know that guy on the right. The fellow on the left is Robert Millikan. And Robert Millikan, another Nobel Prize winner, won it in 1923 because he determined the charge on an electron. And this was really groundbreaking research at the time. And he did it with this little gadget there. That is the device in which he did what came to be called the oil drop experiment. Basically what happens is you kind of squirt oil into that chamber, and then between two electrical fields, if you can get a drop of oil to hover there, you can determine the charge on an electron. It's a really easy version of it, but that's basically how it works. And in fact, this is now such a famous experiment, you can even buy one of these things. You go online and for almost $400 you can buy a modern version of the oil drop experiment. They do them in, I'm sure they've done them in the physics labs here at the University of Utah. It's just a kind of standard experiment now. Here's the hitch though. That fella there is Harvey Fletcher. He was a son of Mormon pioneers. He went to BYU, got his degree there. And then he went off to the University of Chicago to study under Millikan and get his degree there. When Fletcher got to Chicago, it wasn't the oil drop experiment, it was the water drop experiment. And they were getting nowhere. They couldn't get the damn thing to work. So Fletcher's idea to switch from water to oil. Oil ends up working. Fletcher then runs many of the experiments right alongside Millikan. And Fletcher also ends up writing up the manuscripts with Millikan to talk about the results. This is a more recent photo of Fletcher. He died in the 1980s, but he went back to BYU, invented the hearing aid. It wasn't such a bad gig. But anyway, let's go back to 1913. They've got 5 publications ready. First one's going to be the big one that announces the charge on the electron, and then the next 4 are going to be kind of follow-up things talking about other experiments that they've done. And in an interview that Fletcher agreed only to have published after he died, he explains how the decision about who was going to be authors on the paper were made. All right, here's the ethical dilemma in this one. Okay, it's Millikan's original idea, it's Millikan's original design. Fletcher comes along, makes significant contributions to how they actually perform the experiment, to running the experiment, and then actually writing up the results. Again, we got a question of authorship. Who's going to be on the papers here? And so in this paper, in this interview that he only agreed to be published a year after he died, this is how he explains it. Answering a knock, I went to the door and was surprised to see Millikan. I wondered why I'd come to our humble abode. I soon found it was to decide who was to be author of the paper referred to above. This was the first paper. There were 4 other papers in the stages that were coming out of these oil drop experiments, and I expected they would all be joint papers. He said that if I used the published paper for my doctor's thesis, I had to be sole author. It was obvious he wanted to be the sole author on the first paper. I didn't like this, but I couldn't see another way around it, so I agreed to use the 5th paper as my thesis. So basically, they've been working on all 5 papers together. Millikan shows up and says, tell you what, you need a paper on your own to do your PhD thesis. So I'll give you the 5th one, I'll take the 1st one, and then we'll joint author the other 3, right? Basically bullied the young guy out of being a part of the paper that ends up leading to his Nobel Prize, right? There's another example of what you do in ethical dilemma. One last example. Anybody recognize what those photos are from? Tuskegee syphilis study, that's right. So in the 1920s moving into the 1930s, the U.S. Public Health Service was interested in fighting and hopefully eradicating venereal diseases, and in particular syphilis. So they found this small town in the South, and the initial goal was to go in there and treat syphilis such that it would disappear. The problem was, this was right as the Great Depression was hitting. And so they went down in there, they enrolled a bunch of people into the study that they now knew had syphilis, and the money that was going to be funneled to them to treat the syphilis was no longer available because the Depression dried it up. So now they had an ethical dilemma. Well, we've enrolled all these folks, it was all guys, into this syphilis study because we're going to give them treatments. And now we don't have a treatment, so what are we going to do? Their answer, well, we'll just keep studying it to see how the syphilis develops in their body, and we'll tell them we're giving them treatments. And so they would give them various placebos. They also gave them special treatments. That's a picture of one of them getting a spinal tap. The spinal tap has no medical relationship to treating syphilis. It was very dangerous, and in fact, you could be paralyzed as a result of it. But it was important to get spinal fluid because they wanted to see whether or not the syphilis was spreading through their body and if it was in their central nervous system. That happened in the 1930s, 1940s. Another important ethical decision arose in this study where right around World War II, we suddenly understood how things like penicillin worked, and that penicillin could be used to attack various diseases like syphilis. Following World War II in the late 1940s into the 1950s, there was this nationwide effort to eradicate venereal diseases and again syphilis. And so they would go to communities with what they now know as penicillin and give them to folks so that syphilis would stop being continuing to spread. The one exception, the guys that were enrolled in this study. These folks were systematically kept out of any treatment for syphilis and kept away from penicillin because the Public Health Service wanted to continue to see how the disease coursed through their body. Okay? It wasn't until 1970, I imagine there's people in this audience that were alive who might even remember this. It wasn't until 1972 when the Washington Post finally broke that for 40 years our own government's Public Health Service with taxpayer dollars was tracking syphilis in this poor, illiterate group of black men from the South just to see how the disease progressed. There was also a twist that came out in 2010. Did you guys catch what happened in 2010? So a historian was going back and looking at some of these old records from the syphilis study, and the one, if you can call it a redeeming quality, the one redeeming quality from this episode is that we didn't actually infect anybody with syphilis. They just found people with syphilis, and then when we had a treatment, we didn't give it to them, and lied to them about special treatments like spinal taps. It gets worse, though. It turns out there was a second arm of this study taking place in Guatemala, funded by the Public Health Service and funded by American scientists, where they were actively infecting prisoners over there with syphilis. Usually what they would try to do is just find prostitutes who were infected with syphilis and tempt the prisoners. And then on rare occasions, if the prisoners kind of restrained from the temptation, they would just go ahead and infect them with syphilis. So this was emerged in 2010. President Obama had to call the president of Guatemala and say, I'm really sorry, this is all coming out again. So again, here's another example of kind of what to do in an ethical dilemma. You take advantage of a poor, illiterate population and use them to answer scientific questions you might be interested in. So I want to kind of draw out 2 lessons from this. We've seen a couple different responses to ethical dilemmas. Right? We've got Watson, who got the final bit of data he needed but couldn't get on his own from Franklin, and then goes off and publishes without her. We've got Millikan, who bullies Fletcher out of joining him on an article that announced the research that they were doing together. And then we've got the famous Tuskegee syphilis study, where a vulnerable population was taken advantage of to answer a scientific question. should be clear here, right? I don't want the kind of take-home lesson of this to be, this is what scientists do, right? Nobody thinks that all scientists are bad, that everybody on upper campus is kind of a mad scientist thinking about, you know, how do I get my hand on a vulnerable population to do all sorts of Frankenstein experiments, right? Nobody thinks that, right, your average professor in the neurobiology department is thinking about how do I bully my grad student out of joining me on a paper. This is by no means the norm. But it is the reality. It is the fact that in these certain ethical dilemmas, and you notice it's often when the stakes are very high, like Nobel Prizes are, you know, on the line, that scientists historically have at times behaved unethically. So in response to this, in part because of this history, starting in 2009, the National Institutes of Health and the National Science Foundation began mandating education in the responsible conduct of research for all students that were getting funding through their bodies. So if you got taxpayer dollars through the NIH or the NSF, you had to get some training in the responsible conduct of research. And this was in part in response to this history that everybody was now aware of. And so, you know, now every semester on the university grounds, we teach a responsible conduct of research class. And people are trained in these various things: human subjects research, publication and authorship, research misconduct, mentorship, class of science. And not surprisingly, the 3 episodes that I just told you about are often held up as, hey, don't do this, right? So when we talk about human subjects research, inevitably it starts with, well, usually the Nazis, and then people say, yeah, but I'm not a Nazi. And then you say, well, what about Tuskegee? And you can no longer say, yeah, but I'm not a Nazi. Right? It was done here. When we talk about publication and authorship, you talk about Watson and Crick and how they took advantage of Franklin. And when you talk about mentorship, you talk about Millikan and how he took advantage of Fletcher. These episodes are now kind of, in some sense, defined on the black and white spectrum. Here's what you don't do in these situations. So with that brings me back to Darwin. Remember, we left him having received a manuscript from Wallace, right? He's been spending 20 years collecting data for an idea that he developed in 1938. And now Wallace has sent him a manuscript that essentially has evolution by natural selection. And he thinks all my priority, all my, you know, achievement here is being whipped away. So I think we can, you know, ask ourselves, well, what should Darwin do, right? And it's important to keep in mind that he had a variety of options available to him, right? He could have ignored it. He could have just thrown it in a drawer or thrown it away and pretended it never arrived. Like, this isn't the age of email. This guy's in Malaysia, and we're talking weeks to months for anything to travel from one side of the world to the other. And so ignoring it would have more or less snuffed it out. He could have followed Watson's lead. He could have looked for a point in Wallace's manuscript, or maybe Wallace had an idea that Darwin didn't have. And he could have taken that idea and finished putting together his theory with the idea that he didn't have. He could have followed Millikan's lead. He could have wrote back and said, hey pal, don't waste your time. I've been doing this for 20 years and I got the same idea. And so if you think you're going to scoop me on this, you got another thing coming. Right? So it turns out he didn't do that. Darwin realized that he had a real conflict of interest in the matter. He was invested in this in a very real way and realized that this young guy, Wallace, coming along and having the same idea, he was not in the best position to decide how to proceed with this manuscript. And so what Darwin ended up doing is first turning Wallace's manuscript over to Charles Lyell, that's again him on the there, and asking Lyell, hey, what should we do here? Okay. Lyell suggests, well, maybe we'll proceed with a joint presentation. Darwin says, I like the idea, but we should get at least one more opinion, and so they pass it on to Hooker. Hooker and Lyell were both kind of the preeminent men of science in England of the day. And again, he says, Hooker, what do you think we should do here? Hooker agrees, we'll proceed with a joint presentation. And so that's essentially what happened. On the 1st of July, 1858, to the Linnaean Society, 2 papers are presented, led by Lyell and Hooker. Wallace's on the tendency of varieties to depart indefinitely from the original type. And then they also present 2 things from Darwin. One is an essay that he had written way back in 1844 that lays out his theory of evolution by natural selection. And they also provide a letter Darwin was corresponding with an American biologist, Asa Gray, about his theory, and so 1857 is an even more developed theory of his theory of evolution by natural selection. And that allowed, essentially, Darwin to, well, it allowed them to present both theories at the same time, but it established Darwin's priority as he got there first, right? So the reason he gets to 1844 and 1857 was to show that it wasn't just a malarial fit 3 weeks ago for him. He's had this idea for decades. Interestingly, neither Wallace nor Darwin were there. So Wallace, remember, is halfway around the world. He doesn't even know this thing's happened. Darwin's son was dying at the time. In fact, he died just 3 days before that, and his son was dying of scarlet fever throughout that entire month. And so he was in no position even to kind of deal with it. And so he was only told about it after the fact. So that brings us back to Darwin and Wallace. Every 50 years now, they award the Darwin-Wallace medal on the 1st of July, 1858. So the most recent episode was in 2008, and another handful of evolutionary biologists were given the Darwin-Wallace medal. I think it's worth kind of taking a step back here and evaluating how Darwin handled the situation. Right? What he realized was he had a conflict of interest. And when you have a conflict of interest, you are not the person to decide how to deal with proceeding with it. Conflicts of interest need to be independently managed and independently reviewed. Okay? And Lyell and Hooker realized that independent discoveries deserve independent recognition. And those ideas of conflicts of interest deserve independent management, and independent discoveries deserve independent recognition. Those are still just standard principles of responsibly conducted research. When this course gets taught, and you cover conflict of interest, you talk about independent management review. When you talk about authorship and independent discovery, you get independent recognition. So it's quite a contrast with some of the other approaches that we've seen. I think the best evidence, though, for thinking about how Darwin handled the situation is how both he and Wallace referred and considered each other after the fact. In some cases just after the fact, and in some cases years later. Because that really gives the best evidence of how did Wallace think this was handled, and how did Darwin think this was handled. So this is a letter from Darwin to Wallace that was just in January 1859. Remember, he's basically in the middle of writing The Origin of Species right now. It's not going to be published until November 1859. The them in this sentence is Lyell and Hooker. I owe indirectly much to you and them, for I almost think that Lyell would have proved right, and I should never have completed my larger work, for I found my abstract hard enough with more poor help. Everyone whom I've seen has thought your paper very well written and interesting. It puts my abstracts from 1839 to shame, or in the shade. And so Darwin was very quick to say, he didn't just realize that he was scooped, he also recognized that Wallace was a very clear and explicit writer, and was very good about summarizing the ideas, and in fact was better at conveying them than even Darwin. I think a more relevant testimony comes from Wallace, and this was something that he said at the first 50th anniversary, the first awarding of the Darwin-Wallace medal. So this was the 1st of July, 1908. This was at the very end of his life, and they gave him an opportunity to come. Darwin was already dead. They gave Wallace an opportunity to come and kind of reflect back on the episode. This is what he says. What is often forgotten by the press and the public is that the idea occurred to Darwin in October 1838, nearly 20 years earlier than to me, and that during the whole of that 20 years, he'd been laboriously collecting evidence. How different from this long study and preparation, this philosophic caution, this determination not to make known his fruitful conceptions so he could back it up with overwhelming proofs, was my own conduct. The idea came to me, as it had come to Darwin, in a sudden flash of insight. It was thought out in a few hours, it was written down with such a sketch of its various applications and developments as occurred to me at the moment, and then sent off to Darwin. I was then, as often since, the young man in a hurry. He is a painstaking and patient student, seeking ever the full demonstration of the truth he discovered, rather than to achieve immediate personal fame. I think that really conveys. If there's anybody who's going to weigh in on this situation, it's Wallace, and I think that really is a testament to Darwin. Let me kind of bring this back full circle and close by talking a little bit about responsible conduct of research. And then we'll have a little bit of time for Q&A. So I teach the responsible conduct of research here at the University of Utah. And every fall, we have a class of almost 150 PhD students that kind of mosey into class and think, oh, I can't believe I have to be taught ethics, right? And it's my job to kind of convey to them, no, actually, this can be really interesting. We talk about Darwin, we talk about Millikan, we talk about Watson and Crick. When I first set out to teach this course, I was familiar with all the shady episodes from the history of science. I knew about Watson and Crick taking Franklin's data. I knew about Millikan bullying Fletcher. I knew about Tuskegee. And so I emailed this history of science kind of listserv, or history of science group. And I basically said to them, look, I'm familiar with these episodes of irresponsibly conducted research. Can you give me examples from the history of science of responsibly conducted research, right? We've got all these examples of when ethical dilemmas arise, scientists behaving pretty poorly. Can you give me some examples of where scientists kind of went above and beyond? And it was interesting. There were the kind of random examples of, say, a whistleblower, like somebody that thought they saw something that shouldn't be happening and blew a whistle. Some people mentioned maybe scientists who were proven wrong and then admitted they were wrong, so maybe they were in a debate with somebody and then final crucial bit of evidence comes in and the person says, you're right, you got me, I'm wrong. They also talked about episodes where maybe scientists regulated themselves and when they were performing dangerous research on, say, recombinant DNA or doing research on viruses that have the potential to create pandemics. But what I thought was most interesting is when it came to the question of a senior scientist treating a junior scientist extremely well, the society kept going back time and again to Darwin. This was the example that people held up again and again as somebody going above and beyond in doing what was right. And so, to conclude, I think, as we're throughout the world today asking ourselves, what is Darwin's scientific legacy? I don't think it's heresy to say, what would Darwin do? Because he very much did the right thing, and he continues to represent an example of how to behave in these situations. And unfortunately, the history of science isn't replete with these examples. Thank you very much. Is there a form? Okay, go ahead.
I was wondering, have you looked at patent law at all? There's a big effort here at the University of Utah and many universities to have a U-Star, which is a privatization, really.
Technology commercialization.
Well, it's really a privatization of research, I think, because of lack of funds. But anyway, the question is, it's very common in patents to see the boss's name attached to a patent, when in fact the boss often had nothing to do with it.
Yeah, because when money's at stake, it's not just about priority and fame, it's about potentially being the millionaire as opposed to the 10,000-aire, depending on where you're listed on that research. That's right. The University of Utah shows great credit every year. It's at the forefront of essentially commercializing research. We've got the U-Star that you mentioned, we've got the Technology Commercialization Office. And basically what they do is find innovative ideas that are in our community and think about ways that they can commercialize them. And you're absolutely right. Now it's not just about fame, it's about fortune, and the stakes can be held high there as well. Yeah. Yes, Jason, I think this is your hand first.
Oh, okay. Well, I was just wondering, given what you know about the topic, what would you predict would have been the outcome of this situation between Darwin and Wallace if it occurred today?
So the question was, what would have happened today? Well, the easy answer, I don't know. I mean, I think it certainly is the case. Well, I mean, let's just do it this way. Bump from Darwin to Watson and Crick. I mean, I think that's the most recent example, or even Millikan, right? Here's part of the problem. People don't do science like Darwin and Wallace anymore, right? I mean, science is this huge collaborative effort. Many, many people are involved. That's why you get these debates about authorship. It's publicly funded, right? At this time, you're basically independently wealthy, and you could go off and do your own thing and publish when you were ready, and you would just be the only author. So I would say, it's unlikely that you would even find something like this these days, where someone has just been kind of milling over an idea for 2 decades and then they come out with it. I think more likely the problem are things where there are multiple people working on a project, and whether it's for financial reasons or just an interest in fame, they make decisions either about who to exclude that maybe somebody should be on, or maybe they include people but they reorder the names. And as he said, it can be standard practice. We're starting to get away from this. They just kind of automatically list heads of departments or chairs of departments as the senior author because it came out of their lab. Journals are starting to kind of dissuade that and even explicitly disallow it. But, you know, debates about authorships happen all the time, yeah, for better or worse.
So you may be aware of this, but recently a medical school just outside of Chicago renamed itself the Rosalind Franklin Medical School.
Yes.
So just a nice little... Sorry?
I didn't know that, so thank you for telling me that. No, I think Rosalind Franklin, one of the really shady things about that episode is Watson continued to kind of belittle her for years afterwards, and he wrote this book, The Double Helix, that came out in the 1960s, and it just completely kind of dismissed her as this kind of frigid know-nothing who really just kind of didn't appreciate what she had access to, and so she really needed our eyes on the data to make sense of it. And it really wasn't until the 1970s into the 1980s, and you even see them come out now, where historians went back and did histories of this episode and realized that Rosalind Franklin had a whole lot more than anybody imagined at the time, and in fact was closer than any other individual. And I think you're right, she's now kind of getting her fair due. It's unfortunate because she was died, they don't award the Nobel Prize posthumously, so she didn't have access to it. But I think the thought was, if she were alive, it probably would have been Watson Crick and her. Sure.
The other comment I wanted to make, and it's more of a comment, but I loved what you said, but what may not be quite so clear to the general audience is these things which we saw two beautiful examples of the ends of the continuum really are a continuum, as just was alluded to a little bit more explicitly just here. So the whole issue of authorship is a challenging one. The whole issue of who gets the Nobel Prize, the person who is the head of the lab or the student working for that person. These are not easy questions, and this is what makes it, the course you teach, so relevant, because these are not just things that happen once every 50 years. They happen every day, right? And one extreme is somebody comes in the lab and the advisor tells the person exactly what to do, and they do it, but if it hadn't been he or she, it would have been somebody else. Well, that's a pretty easy one, right? And the other one is where the student comes in and totally on his or her time and without really any knowledge or input to the advisor develops this idea and implements it all by him or herself, and that's a pretty easy one. But that's not how any of these things work. And so the issue of where do you draw the line, we all go to conferences, we all find data from other people, we all find data that's published on the web, and then we take it and then we use it for our ideas. And at what point then does this person who didn't directly interact with us deserve credit, right? I mean, these are challenging questions, and it really is a continuum. So I'd just like to encourage people to think about the fact that these guidelines, which have now stood the test of time for quite some time, were really innovative then, and yet they still serve as very useful guideposts. Yet, despite that, these ethical challenges remain in some ways just as fraught with difficulty as they've ever been.
Yeah, well put, I agree with that. Yeah, please.
Did either Darwin or Wallace realize how big a finding they had?
Well, so did Darwin and Wallace realize what a big a finding they had? So, kind of two answers to that. Darwin certainly recognized that he was on something very, very controversial. And in fact, his wife was a devout Anglican, always worried that his theory meant that they might not find each other in heaven. So he knew on a personal level that this was really going to attack people's religious worldviews, and he knew that it was going to be controversial. So in that sense, he had a sense of how big it was. The other interesting thing is, at the end of 1858, when the Linnaean Society gave their kind of annual report of what happened that year, so this would have been the report on what happened in the year that the Wallace-Darwin manuscripts were read. It interestingly said, nothing of interest happened this year. There were none of those groundbreaking discoveries that people immediately recognized as important. So there's this sense of, in 1858 they didn't realize it, but when the book comes out a year later in 1859, it's immediately recognized as huge. Yeah, sure.
Could you just comment a bit on why it's Darwin Day and not Wallace Day? Obviously,
right.
One of these figures has risen a lot. There is this example of the coin, and those familiar with biology obviously have a sense of both their contributions.
Right.
But it's, you know, it's like Microsoft and WordPerfect. We know this other one exists, but who cares?
So I think there's a couple reasons for that. One is, so just the fact of Wallace hit on the idea in this malarial fit and then write the manuscript. And Wallace was just basically honest about it. This is how it happened. And Darwin had 20 years of data. That was kind of what Wallace had to say about it. And then a year later, Origin of Species comes out. It was very clear this was Darwin's big idea. And Wallace is recognized as being the kind of guy who independently got there. What happens though after the fact also is Darwin kind of continues to write about evolution. He goes on and talks about the descent of man. He does a book on earthworms, and he continues to write evolutionary biology. Wallace was kind of weird. He had all sorts of kind of odd spiritual ideas, and so Wallace made a variety of kind of intellectual and personal decisions that kept him on the outside of the scientific establishment. And he was also, I mean, to his great credit, he always held up Darwin as his idea. And so when Wallace finally did write his big book on evolution by natural selection, the title of it was Darwinism. So it was self-imposed as well. Yes, please.
Do you think that there was an ethical concern that maybe they addressed of Darwin publishing Wallace's work without Wallace's consent?
That's a good question. Yes.
And especially with Darwin feeling that it was so important to not publish for so long.
That's right. So, yeah, I think that it seems to me if there was one concern you might have, it was the thought that they didn't get Wallace's permission first. And so I think there's a kind of, the practical response is, well, this would have taken probably 6 months to get a letter to Wallace and then have him confirm and then send back. And so I think just the kind of practical problem is what made them choose not to. That said, it is very clear when Wallace found out, he was just absolutely thrilled. I mean, he couldn't believe that he was now kind of in the same boat as Darwin, and his paper was presented alongside Darwin's. So the kind of closest thing I can think of comparing to nowadays would be if, some kind of MS student in our physics department learns that while he's traveling, maybe for his honeymoon, he hit on the same idea as Stephen Hawking, right? And they present at the kind of international physics, I don't even know what they would call it, international physics presentation, right? Hawking, it turns out, has been working on an idea for 20 years, and this guy at the University of Utah, in a master's program did as well, right? Probably he's not going to be thinking, oh, they screwed me, right? They should have contacted me. He's probably thinking, oh my God, right? They presented my paper next to Hawking. So I think you're right. You probably hit on something that could have been a concern, but it doesn't seem to have bothered Wallace at all. Yeah.
I think it's important to remember that Wallace started outside of the mainstream.
Yeah, that's right.
He was several class picks down from Darwin, and he was sort of everybody's field assistant. He went around for hire to all these places no one really had time to go, and collected stuff for them.
That's
so
right.
He's this young guy barely scraping by, sending money back to his family, and he sends his manuscript to Darwin sort of like, hey, I'm thinking of maybe publishing an idea like this.
Yeah.
What do you think? So he's like beyond thrilled that anyone of that level cares, and would just go ahead and publish it for him. The other thing that Darwin did after the fact, when Wallace sort of went a little crazy and everything and still had no money, is he set up a pension fund for him for the rest of his life.
So I didn't know about the latter. That's really interesting.
Yeah, yeah.
What I'd say about the former, so I think that is really important. Yeah, I mean, certainly you still see it a little bit, but in Britain in that day, there was a very rigid class system. And Darwin, Lyell, Hooker were in a very high class. And Wallace was coming out of a working family. And I think the fact that Darwin and Lyell treated him so fairly despite this is again a kind of testament to the ethical behavior that they chose, because I think then the closest analogy is again Watson and Crick dealing with Franklin. When you're talking about biology at Cambridge in the 50s, it was a very man-oriented, misogynistic system. And so when people kind of try to defend Watson, a lot of times what they'll say is, well, she was a woman, and that's just kind of what they did to women at the time. Right? And so it's this kind of appeal to, well, people just behaved like that, right? And I think that's all the more reason we should kind of look to Darwin and say, wow, this is really impressive, because it would have been entirely easy just to ignore it and throw it away. If Wallace had come back and said, hey, I had this idea, nobody's going to believe him or even really care.
Well, and the other thing I wanted to mention is that when you read the two side by side, it's blatantly obvious that they didn't come to the idea from the same starting point, actually opposite starting point. Darwin takes artificial selection and says, here's this kind of case study, I'm going to use this to illustrate how this might happen in nature. Wallace kind of says, artificial selection happens, but it's sort of bullshit. So let me tell you in 8 pages what my idea is.
Yeah.
So there's absolutely no way that ideas could have gotten stolen.
Yeah.
If you actually just look at how they lay it out.
Yeah, that's right. It is interesting, though. A couple books emerged in the 1980s that the thesis was basically Darwin and Lyell stole Wallace's idea. So the thought was Darwin was kind of putzing around in the 1830s, 40s, and 50s and wasn't getting anywhere. Wallace's manuscript comes along, and now they're like, wow, this is great. We can finally do something with all this research we've been doing. And so basically Darwin steals the idea, and Lyell kind of sets it all up. So then this is certainly what we've been talking about today is the received view. But I think it is interesting that there are still these kind of outliers that kind of like the idea of, no, actually there was this young guy who got kind of stomped, right, a kind of Harvey Fletcher Millikan story. But the historical facts just don't support that. Yes?
I guess another implicit message that that has resonated through the history of science is that, let me put this crudely, as I was once told, being in a similar situation but at much lower scale. Well, ideas are a dime a dozen.
Mm-hmm.
And the reality is when a person's work is evaluated as a whole, it's not simply a short statement or something that you wrote, but what did you do beyond that? And what basically happens, rightly or wrongly, but empirically, is that when someone has a whole body of work over their lifetime just making the case, then people implicitly or explicitly defer to that huge body of work as being the dominating influence. And the flash of insight is absolutely appreciated, but by itself doesn't really hold up the same way that a flash of insight plus 20 years worth of work carries credibility.
They both have the flash of insight, but then Darwin followed it up with at least 20 years of data and then went beyond that. Yeah, maybe one more question.
Suggestion. It might be good to move this from 19th century science to more 20th century technology, especially in your graduate students, where they're going to use star stuff. And I ran into an example recently that I don't know the whole story. But when the Wright brothers invented the airplane, they made a patent called the flying machine. And within months, there was a guy from California at a religious school that wrote a patent called the aeroplane. And he died in a crash because he was one of those old experimentalists, longer than Wright brothers. But because he was secretive and died, the family mishandled the lawsuit. Now that would be, and I think there was another player in this, but that would be a great story because it's early in patent law. And it kind of is a segue to move from a scientific debate early in the 19th century to an early 20th century one, the beginning. Because one of the things I think that's true is that our understanding from metaphysics to technology is an exponential growth, not a linear one. And so I just think it might be a good segue.
That is helpful. I think it captures nicely the world we live in now. Because certainly, right, Darwin wasn't thinking, can I patent it? But the reality is now it's both fame and fortune that are on the table. Well, if anybody's interested, I went ahead and I would think if there's anybody in the world that would be interested. I made some bumper stickers of that, and I've got about 10 or 15 here. And so, if it's something that you'd be interested in, I'm happy to kind of hand them out so you guys can spread the gospel. Thank you. Happy Darwin.
So you fit all that on your phone, dude? You good?